Introduction of spline curve. Introduction of spline curve. So let me define what is the meaning of spline curve. The spline curves are piecewise polynomial curve. We can say that it is a piecewise polynomial curve. So what is the meaning of piecewise? So piecewise means it is consisting of small pieces. So you can say that it is consisting of small pieces. Right. So if I say that we are having one piece, this one, and the second piece is this one, there is no issue. So this is your one piece P1, I can say this is your piece number 2. Right. Now this curve is consisting of two pieces, let's say that, and your spline curve is also a piecewise polynomial curve. Then what is the application of the spline curve? A spline curve is used in your automobile bodies model creation, and it's also used in the creation of animation path. So we can say that the spline curves are useful to create animation path and construct the model of automobile bodies, etc. So many applications you'll find that. So whenever you are going to create a path, just think about this, the path you have created using spline curve, and we want to use this path for animation purpose. Suppose a butterfly which will begin from this point and it will go up to this point. Now from starting point to ending point, the butterfly will fly from your one end to another end. So this curve will be helpful for that butterfly for its movement. So that's why in animation the path is created by the spline curve. Similarly, we have different automobiles, and the outer appearance of the automobile can be easily constructed by the spline curve. In computer graphics, the spline curve is represented by different points. Just here I have explained to you. We can say that in computer graphics, I am writing in short CG, spline curve is represented by set of points called control points. Now I can say you that Your computer graphic spline is represented, spline curve represented by the set of points. So now we can say that here is a one point, I can write here one more point, I can write here is another point, I can write here is another point. So we have so many points are there, and the points are helpful to create the shape of the spline curve. Now those points are called the control points. Let me go for one more example. The control points decide the shape of your spline curve, and the position of the control points decide the type of the spline curve. We can manipulate the control points to change the shape of spline curve. So there are two types of spline curves. There are two types of spline curve. The first one is called interpolation spline. Interpolation spline curve. And second one is called approximation spline curve. So that two types of spline curve we can construct on the basis of the position of the control points. So what do you mean by the interpolation spline curve? If all the control points pass through the curve, then we can say that curve as interpolation spline curve. So what is the meaning of if all control points pass through the curve, then it is called as interpolation spline curve. For example, just think about, we have certain points. So now the curve passes through all the points. Then we can say that it is interpolation spline. So this is your P1, let's say this is your P2, let's say it is P3, let's say it is P4, and so on. So okay, so second type of spline curve is approximation spline curve. So what is the meaning of approximation spline curve? If some of the control points pass through the curve, then it will be called as approximation spline curve. For example, in this spline curve we have four control points, P1, P2, P3 and P4. So P1 and P4 they are passed through the spline curve, but P2 and P3 they are not passed through the spline curve. If some of them are passing through the spline curve or some of them are not passing through the spline curve, then it will called as approximation spline curve, because some points are approximately close to the curve. And in order to be a spline curve, we need to follow some property. So what is that property? Because in your spline curve concept, we know that spline curve is consisting of small pieces of curve segments. So just imagine that we have segments like your S1 is one segment, there is another segment is S2, and from this to this point there is another segment. So if I say that this is your point P1, this is the point P1, and this is your control point P2, this is P3, let's say this is a P4. If you have 4 number of points, so we have 3 segments. So in order to maintain the continuity, we need to follow some property. If there is no continuity, then we cannot form a smooth curve. So as per the spline curve concept, we should draw the curve in one go. Without raising your hand, if you can draw a curve, then we can create a smooth curve or a continuous curve. If you are moving the hand or raising the hand from the paper and then again you are drawing, then you can find there is a gap. So in your spline curve, the continuity should be maintained. In order to be continuous curve, then what should we do? We need to check some condition. So just look at here, we are making the curve by joining the small pieces. I told you that we have your one piece is here, there is another piece is here, and the piece is here. So 3 pieces, and we are making a curve by joining the 3 pieces. If you want to make the continuity, then the joining point should be same. That means the intersection points of S1 and S2 curve or segment, I can say that the intersection points between the 2 segments S1 and S2 should be same in order to maintain the continuity. So that's why we must ensure the continuity of the curve. We have the 2 types of continuity conditions. How to check the continuity in the computer graphics? We have 2 continuity conditions. The first one is called the parametric continuity condition, and the second one is called geometric continuity condition. By using any one of the continuity condition, we can check the continuity in your curve. If there is continuity exists, then we can form a spline curve. So let's move on to the first part, that is the parametric continuity condition. So what is the meaning of parametric continuity conditions? It is defined by the term C superscript n. So the value of n can be 0, can be 1, can be 2. So if the value of n is 0, then we can say that 0 order continuity. If C superscript 1, then we will say that the first order parametric continuity. If C superscript 2, then we can say that the second order parametric continuity. So in order to check the continuity in the spline curve, so we have 0 order continuity, first order continuity, and the second order continuity. So what is the meaning of each continuity? Let's move on. 0 order parametric continuity condition, what is that? The first curve section end. So just think about this is a curve and we have the 2 segments, that is one S1 and another is S2. So the end point of the first segment should be equal to the beginning point of second segment. So if it is same, then we can say that the curve is following the property of 0 order parametric continuity condition. So we have written here, first curve section end point should be equal to the beginning point of the second curve. So first curve is S1, its end point is P2, which is equals to the beginning point of the second curve. So the beginning point of the second curve is also P2. That's why there is the continuity maintained in your curve that is demonstrated here. So that is the 0 order parametric continuity condition. The second parametric continuity condition is your first order. In the first order, we should take the derivative at the intersection point. If the derivative is the same at the intersection point, then we can say that it is a first order parametric condition is satisfied. The derivative, so here we done that the derivative is same at the intersection point of two adjacent curves. So this is the curve and the two adjacent curve. I can say one is S1, another is S2. So the intersection point of two adjacent curve S1 and S2, I can, or segment, we can say that is P2. You take the derivative at that point. If you are going to take the derivative, it will give you slope of the tangent line at the intersection point. So I can say that here we will get one kind of tangent line. So the first order derivative, we can say that it gives slope of tangent line at intersection point. So two curve segments are intersected at your P2. So this is the intersection point. So if you need to take the first order derivative at your P2, if you are going to take, so it will give you the slope of the tangent line at the intersection point. So we can say that both your segments S1 and S2 is following the concept of the continuity, provided they are sharing the common tangent. If they are sharing the common tangent at the intersection point, then we can say that the curve is maintaining your first order parametric continuity condition. Then let's go for the second order parametric continuity condition. So your third parametric continuity condition is second order. So here we will take your second order derivative, second order parametric continuity condition, second condition. So as I said earlier, the second order parametric derivative, the second order parametric, I am writing short, parametric continuity derivative, if the second order derivative of one piece or segment should be equal to the second order derivative of next piece or segment. Alright, so if you have a curve, let's think about the spline curve, and the spline curve is maintaining your continuity. So we have to take the second order derivative of one piece should be equal to the second order derivative of the next piece. So if you are going to take the second order derivative at the intersection point, if both are equal, then I can say that it is following second order parametric continuity condition. So next is geometric continuity condition. Geometric continuity condition. In your parametric continuity condition, you are writing C0, C1, C2. In geometric continuity condition, you write that G superscript 0, G superscript 1 or G superscript 2. In G superscript 0, we will say that there is zeroth order geometric continuity condition. In G1, that will be called as your first order geometric continuity condition. G superscript 2 will be called as second order geometric continuity condition. So it is the alternative method we can say that this is an alternative method for joining two successive curve section. So as I told earlier, so whenever you are drawing a spline curve, so the curve should be visible as if it is drawn in one go. There should not be any discontinuity, and the geometric continuity condition is helpful to check that continuity. So it will check the joining point should be same. What is joining point? Joining point between the first segment and the second segment. If it is same, then we call it as zeroth order geometric continuity condition. So similarly, your G1 and your G2 can be written as similar to your first order parametric continuity condition and the second order parametric continuity condition. So next video lecture will think about representation of spline curve and representing your cubic spline curve.